Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 8, 2025, so just late last week. This paper finds that even the best multimodal large language models, which are AIs designed to understand both images and text, are significantly challenged by real-world math problems, with a top model only achieving 53.9% accuracy on a new, more realistic test. The paper is titled, MathReal, We Keep It Real. A real-scene benchmark for evaluating math reasoning in multimodal large language models, and the author's analysis of why these models fail is really quite revealing. They created this benchmark from thousands of real photos of math problems, taken by K through 12 students on their phones, to see how today's models handle the visual messiness of the real world. Also worth noting, the project code is available on GitHub for anyone who wants to explore it further. Alright, so here are a few examples from the MathReal dataset which really highlight the kinds of challenges we're talking about. We can see the 3 question types they use: multiple choice, fill in the blank, and constructed response. More importantly, you can see the real-world messiness, like blurriness, photos taken at an angle, and even handwritten notes. The authors score each image on these factors, including image quality degradation, perspective variation, and what they call content interference, which is basically just irrelevant extra stuff in the picture. Moving to the results, this radar chart shows a performance comparison for 6 different models across 5 math problem categories. The authors use 2 scoring methods. The larger, outer-colored shapes represent loose accuracy, which allows for partial credit on answers. The smaller, inner shapes show strict accuracy, where the model must get every part of the answer correct. We can see the Dubow 1.5 Thinking Vision Pro model, in red, generally performs best, but even it struggles, especially with logical reasoning problems. This table then details the composition of the MathReal dataset itself. The full collection has 2,000 questions, with a smaller test mini subset of 480 questions used for the main evaluations. It's also designed for complexity. You can see a majority of questions involve multiple figures or multiple sub-questions. The problems are spread across elementary, middle, and high school levels, ensuring broad coverage of K through 12 mathematics, which really sets the stage for a tough, realistic benchmark. To better understand where these models struggle, the researchers designed an experiment to separate visual perception from pure reasoning. This bar chart shows the results. For each model, the different colored bars represent different levels of help it was given. For example, the pink bar shows accuracy when the model only sees the raw, messy image. But the blue bar shows performance when it also gets a perfect, human-verified transcript of the question and figure. The massive jump in accuracy for every model shows that just perceiving the content correctly is a huge hurdle. So, in conclusion, the key takeaway is that current models are still too fragile for real-world educational use. They struggle with both visual noise and the underlying mathematical reasoning itself, showing there is a long way to go. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.